guys, welcome back to the 5th session of Chapter 5. The content of this session is modified duration, which is developed from Macaulay duration, which is also the content of our last session. Now, let me refresh your memory with the definition of Macaulay duration. It actually tells us the weighted average time an investor must hold a bond until the present value of the bond's cash flow is equal to the amount we paid for the bond. Now, the modified duration is developed in a way it serves as the coefficient, or let's say the connection between the change in yield and a change in price. Now, let me tell you that the change in yield when we measure the modified duration has to be quite small. Because, well, let's see how the modified duration is calculated. Well, we say it is developed from the Macaulay duration because it adjusts Macaulay duration in a rate of return adjusted way. So we develop the Macaulay duration, we use that to divide it by 1 plus YTM divided by M. So 1 plus an interest rate related factor. So the YTM divided by M, what's M? M refers to the number of payments in a year or the numbers of coupon that is paid within a year. Or we can see that as the number of investment terms within 1 year. For example, we receive coupons every 6 months. So that means an investment term is 6 months long, and there will be 2 investment terms within 1 year. So in this case, M equals to 2. And easy as that. That's how the modified duration is developed. Now we say it is a coefficient because the scholars actually find that the bond price movement will vary, or let's say change, proportionally with the modified duration for a small change in yields. So how small is that? See the change in interest rate here. So it is actually measured by the yields in basis point and further divided by 100. Now, the basis point is a small unit. It is smaller than the percentage unit, right? And we further divide that unit by a 100. So that's how small the change in yield needs to be. And the change in price in terms of percentage is equal to the modified duration times the change in interest rate. Now, remember, there is a negative sign being put on the right side of the equation because the change in interest rate and the change in bond price is actually opposite. It means that when there is a decrease in interest rate, there is an increase in the bond price. We know that because the interest rate is a discount factor for the future cash flows. And if there is a larger discount factor, there is a lower value for present value of the future cash flows, right? So that's why these two are negatively related. And that's why when we calculate how these two relate to each other, we need to put down a negative sign. All right. One thing we notice from this equation is that it actually assumes a linear relationship between the change in interest rate and the change in price. So this is the price yield curve that we have looked at for multiple times in this chapter actually. And we can see that the relationship between price and yield is far from being linear. It is a curvy line. So at best, they are, let's say, curvy, linear related kind of two measurements. However, the modified duration, we assume this is a linear regression. Now, that's how we say the modified duration only offers an approximation. It is not the real change because real change is a curvy function and this equation assumes a linear function. But why we can still look at that, why this is still useful, is because we said that this measures a very small change, a basis change divided by 100. So that is a very small change. And this curve is not that curvy. For example, this is a much more curved line. So these two compared, this one almost looks like a straight line, almost looks like a linear function. And when we talk about a very small part of change in yield, see this part, even though there is some convexity inside of this component, but if we simply assume a linear function, if we just use the tangent line, it wouldn't be that much of a crazy assumption or measurement. It wouldn't be. It wouldn't be far from the reality, and it actually is of our estimation. But it has to be a very small change. If it is like that, there's definitely a curvy line, right? If it is small, relatively a straight line. Now let's clear the board. Okay, now go back. Let's look at the equation again before we actually use that in question. Now, we have the example of a bond. It is a 10-year bond with 12% coupon rate and a yield to maturity of 10%. So, with the lesson from session 1, we know that with a coupon rate being higher than the YTM, it is actually a premium bond. So, its selling price when a bond is firstly issued must be above its par value. So, now we have known that the Macaulay duration is 7.2 years. So we know the numerator when we calculate the modified duration. And assume a semi-annually compounding. So that means M equals to 2 because there is 2 investment terms within 1 year. Now, let's do the calculation. The modified duration equals to the Macaulay duration divided by 1 plus the YTM divided by M. That's it. So 1 plus 5%. And then we have the final result as 8.6 years. We use this to calculate the percentage change in price. If the interest rate declines by 50 basis points, what will be the percentage change for the bond price? Let's put everything we know into the equation. Here is the change in price percentage-wise, and here is the modified duration times the change in interest rate. And remember, we need to adjust the basis point by dividing it with 100. And it is a declining rate, so it has a sign of negative. It means that there is a decrease in the interest rate. Now, we know that when there is a decrease in interest rate, there's actually an increase in the bond price. So, don't forget to put down the negative sign right here. Negative sign times a negative sign equals to a positive, right? So, we have about 3.43% in terms of the change in price, percentage-wise. That's it, easy as that. So it gives us a very quick and direct and not far from the reality kind of estimation. With the modified duration, or let's say the Macaulay duration, actually, when we look at the portfolio of single investments, we concentrate about their interest rate risk other than looking at the term of maturity or let's say the amount of coupon payments. The interest rate sensitivity, we pay attention to that because it allows us to take advantage of the change in interest rate, and particularly when there is a decrease in interest rate. We pay attention to that because when there is a drop in interest rate, there is an increase in the bond price, and we want to capture that price appreciation. We need to change our interest rate sensitivity when we pick up the duration that fits our investment goals. Now, if we are expecting a decrease in interest rate, we want the portfolio of bonds or the single investment bonds to have the largest duration as possible, even a zero coupon bond, because that allows us to experience the highest price appreciation in bond. Now, if on the other hand, we are expecting an increase in interest rate, then there will be a decrease in the bond price. To avoid our capital loss or the price drop in bonds, we need to adjust our portfolios or our single investment of bond to have a lowest duration as possible. Now, we also need to have this idea in mind, that is, when we do that, to look at modified duration actually give us an estimation of the change in price, because it says here that for every change in interest rate, we will have the change in the bond price in opposite direction for every year of duration. But duration here refers to the modified duration. All right? Use the modified durations here. Here is the strategy that we have talked about when, or let's say, why we need to understand the duration and how we can use it in the reality. So this is what we have talked about. And we actually need to realize that it is only an approximation. It is, let's say, it's like the Kant model. It offers the estimation, but the reality can fall far from it. And we need to realize that because we know that the modified duration actually assumes a linear relationship between the change in interest rate and the change in price. And the actual price yield curve tells us that it is not a linear function, but a curvy function, looking just like that. All right? Okay, so that is the end of this session. In this session, we have talked about the modified duration, how we calculate it, how it was developed from the Macaulay duration, and what it tells us, how we can use it in the reality, and what is its limitations. It has to be a small change in yield. And the reason is, well, that is to be revealed by our next session. All right, I'll see you next time. Bye-bye.